Have you ever wondered which planet in our solar system spins on its side? That's Uranus, a unique celestial body that marches to the beat of its own drum. It's not just a little tilted, but a whopping 98 degrees off kilter, causing it to essentially roll around the sun on its side, unlike any other planet. This sideways spin results in some pretty extreme seasonal variations. Each pole gets its fair share of sunbathing, facing the sun for about 20 years at a time. Imagine that. A 2-decade-long day, followed by an equally long night. It's a planet of extremes where the sun rises in the sky, circles around, and sets back in the same direction it came from. So, if you're ever feeling a bit sideways, remember Uranus, the planet that's made it its permanent state of being. Imagine a planet that rolls around the sun on its side. That's Uranus for you. Did you know that Uranus was the first planet discovered with a telescope? Quite a remarkable feat, considering that it was the year 1781, and the telescope was a far cry from the high-powered devices we use today. The man behind this discovery was William Herschel, a German-born British astronomer. Herschel was not looking for new planets. In fact, he initially thought he had found a comet, but after observing its circular orbit, he concluded that it must be a planet. This was a revolutionary find, as it expanded the known boundaries of our solar system. The planet was named Uranus, after the Greek god of the sky, befitting a celestial body found in the vast expanse of the cosmos. Uranus in Greek mythology was the father of the Titans and the grandfather of Zeus, or as the Romans called him, Jupiter. So a new planet was added to our solar system in 1781, named after the Greek sky god, Uranus. What gives Uranus its distinctive blue-green color? That's a question that has fascinated astronomers and space enthusiasts alike. The answer lies in the planet's gaseous composition. Uranus, like other gas giants in our solar system, is mostly composed of hydrogen and helium, but it's the trace amounts of methane in its atmosphere that really make it stand out. Methane is a fascinating molecule, not least because of its ability to absorb red light. This absorption gives Uranus its distinct blue-green hue, setting it apart from the predominantly yellowish tones of Jupiter and Saturn. But it's not just the color that's interesting. The presence of methane also provides us with clues about the planet's atmospheric conditions. While methane thrives, other elements tell a chilling tale. Uranus is one of the coldest planets in our solar system, with temperatures in its upper atmosphere plummeting to as low as -224 degrees Celsius or -371 degrees Fahrenheit. That's colder than the average temperature on Pluto, but don't let its cold temperatures fool you. Uranus is far from a quiet, frozen world. It's a dynamic and active planet, with a system of narrow, dark rings encircling it. Discovered in 1977, these rings were revealed when Uranus passed in front of a star, causing a brief dimming of the star's light. The rings are maintained by several small moons known as shepherd moons, which confine the ring particles within narrow bands through their gravitational influence. So while Uranus may appear serene and placid from afar, a closer look reveals a world of complex and dynamic processes. From its methane-rich atmosphere that paints the planet in shades of blue and green, to its icy temperatures and intricate ring system, Uranus is a planet that continues to captivate and intrigue us. Despite its striking beauty, Uranus is one of the coldest planets in our solar system. But it's this very contrast, the juxtaposition of beauty and harshness, that makes Uranus such a fascinating subject of study. Did you know that all the moons of Uranus are named after characters from Shakespeare's works? Our journey through the cosmos now brings us to the intriguing moons of Uranus. There are at least 27 known moons orbiting this blue-green giant, each bearing a name from the works of William Shakespeare and Alexander Pope, a testament to the enduring impact of literature on scientific discovery. Among this celestial ensemble, there are several small moons, known as shepherd moons, that play a crucial part in maintaining Uranus's ring system. These moons orbit near the edges of the rings, their gravitational pull helping to confine the ring particles within narrow bands. It's a cosmic dance of epic proportions, with these shepherd moons guiding their flocks along the dark rings of Uranus. The most unusual of Uranus's moons is Miranda, named after the innocent and compassionate character in Shakespeare's The Tempest. Miranda stands out for having one of the most varied and bizarre geological surfaces in the entire solar system, a landscape characterized by towering cliffs, deep valleys, and puzzling formations that hint at a tumultuous past. Theories suggest that Miranda's fractured terrain could be the result of extreme tidal heating in its early history, leading to geological upheaval and the creation of its dramatic landscape. Uranus's moons, with their unique characteristics and intriguing names, add another layer of mystery to this distant planet. Their existence speaks of the dynamism and diversity of our solar system, and the more we learn about them, the more questions we have. Who knows what secrets are yet to be unveiled as we continue to explore these distant celestial bodies. So next time you gaze up at the night sky, think of the moons of Uranus, each named after a character from literature, each with a story of its own, orbiting a planet millions of miles away. With such a rich collection of moons, Uranus certainly holds a lot of mysteries. Only one spacecraft has visited Uranus so far. Can you guess which one? That's right, it's the Voyager 2, a product of NASA's ingenuity. This small, unassuming spacecraft undertook an epic journey in January 1986, flying by the blue-green giant and providing us with the most detailed images and data of Uranus to date. Voyager 2's flyby unveiled a world that is dynamically active, despite its frigid temperatures. It showed us evidence of cloud formation, storms, and atmospheric banding, painting a picture of a planet alive, albeit in a very different way than our own. Yet, the Voyager 2 flyby also underscored how much we don't know about Uranus. For instance, the interior structure of this gas giant remains a mystery. While we believe it to have a rocky core surrounded by a thick layer of icy materials and an outer envelope of hydrogen and helium, the specifics are still unclear. We can only speculate based on the limited data we have, and Uranus continues to guard its secrets closely. Another enigma is Uranus's extreme axial tilt. Unlike any other planet in our solar system, Uranus's axis of rotation is tilted at about 98 degrees, causing it to essentially roll around the sun on its side. This unique orientation is believed to have been caused by a cataclysmic collision with a massive object early in its history, but the details of this event and why it resulted in such a dramatic tilt remain uncertain. The Voyager 2 also recorded incredibly fast winds in the upper atmosphere of Uranus, with speeds reaching up to 560 miles per hour. The cause and dynamics of these extreme winds are yet another puzzle for scientists to solve. Even with the Voyager 2 flyby, Uranus remains a planet full of mysteries. It's a testament to the vastness and complexity of our universe and a reminder that there's always more to discover and understand. But who knows? With the ongoing interest in exploring Uranus further, we may soon uncover more of this intriguing planet's secrets. What does the future hold for the exploration of Uranus? As we look to the stars, the prospect of further exploration of this distant gas giant looms large. With its unique characteristics and mysteries yet to be unraveled, Uranus presents an enticing target for future missions. New horizons beckon, and the scientific community is responding. A number of proposed missions aim to delve deeper into the secrets of Uranus. These include plans to study its complex atmosphere, intriguing ring system, and fascinating array of moons in even greater detail. One such mission, for example, envisions a spacecraft equipped with advanced instruments to probe Uranus's atmosphere. The goal? To uncover the composition of its upper layers, investigate the processes driving its extreme winds, and map the atmospheric banding that hints at dynamic processes beneath the planet's cloud tops. Another aspect of Uranus begging for further exploration is its diverse collection of moons. From Titania, the largest of Uranus's moons, to the geologically varied Miranda, these celestial bodies present a wealth of opportunities for study. Future missions may aim to capture detailed images of these moons, analyze their composition, and perhaps even land on their surfaces to glean new insights. Beyond its moons and atmosphere, Uranus's ring system is another target for future exploration. By studying these narrow, dark rings and their shepherd moons, we could learn more about the processes that maintain these intriguing features and perhaps even discover new rings. And then, there's Uranus's unique magnetosphere. Tilted relative to the planet's axis of rotation, this peculiar feature is unlike anything we see on other planets. Future missions could aim to study this magnetosphere in detail, shedding light on its formation and effects on the planet's environment. Despite its distance from Earth, Uranus continues to captivate us, promising a wealth of discoveries in the future. With every new mission, every new discovery, we inch closer to understanding this distant world. And who knows? Perhaps one day we might even set foot on one of Uranus's moons. For now, we look to the future with anticipation, ready to unlock